Hello everyone, welcome to my channel. Today we'll discuss about the water cement ratio and various properties of concrete like fresh properties and hardened properties.
Okay, so this is just for introduction. What is nominal mix? Why it is used? Okay. Then the second most important parameter in the concrete technology, that is water cement ratio. This is very much important parameter in the concrete, because all concrete structures or all concrete activities are done only on the water cement ratio basis. So what is water cement ratio? Its name indicates that it is a ratio of water to cement. Okay, the ratio of by weight of water to weight of cement, expressed as a percentage. So with the help of percentage, all ingredients were calculated according to the particular water cement ratio. See, there are two methods into the concrete mix design. First is we are considering the grade of concrete first, and then calculate the all mix proportion. And second one, we are finalizing the water cement ratio, suppose zero point 0.3, 0.4, 0.5 water cement ratio, and according to that water cement ratio we will calculate the uh, all ingredient proportions. So in both way we can calculate the grade mix design of concrete. So it is one of the most important parameter which govern the strength of concrete. In the on the basis of water cement ratio, your strength can be vary. Okay. So that is also called as the Duff-Abrams law. Means they have established that the relation between the water cement ratio to strength, means as our strength will be increased, sorry, water cement ratio will be increases, your strength will be reduces. You can see from this graph, it is given in IS code 12062, that is for mixed design of concrete. So from this graph you can observe that when the on x-axis there is a water cement ratio, as we are going higher water cement ratio 0.4, 0.35, 0.5, your strength is reduces. Okay, on y-axis there is a strength, and as we are going for the lower water cement ratio, the strength will increases. So that is nothing but the Duff-Abrams ratio now. Okay, so that is the importance of water cement ratio. That's why we are adding admixtures into the concrete, as in last unit we have studied uh, why we are adding the chemical admixtures to maintain the water cement ratio, or we can say without changing the water cement ratio we can increase or decrease our workability of concrete. Clear? So that's why this water cement ratio is important, because it is directly affected on your strength of concrete, and strength is the main parameter of the concrete or the design of structure. Now comes to our main unit part, that is workability of concrete. Means in the workability is nothing but we have to study the flowability of concrete, how it will be behave, how it will be viscous or it having any strength. So all these things, that is workability. A concrete which can be readily compacted is said to be workable, or easy of placement and the resistance to segregation. That is your workability. In simple word, the workability is the easy with which the place in a formwork. The concrete can easily place and molded into the particular formwork of element. That is the workability. It is too loose description of this vital property of concrete. However, workability also vital property as far as the finished product is concerned, because concrete must have workability, such that the compaction or to maximum density is possible. If your concrete makes harsh, suppose at lower water cement ratio, these things happening because their free water is very less available only for mixing of ingredient or for making some heat of hydration cement paste. The free water is very less into lower water cement ratio. If you go towards the 0.35 0.3 0.28 water cement ratio, where your concrete will be very harshly mixed. So in such case you will not get workability, means there is a zero workability. If you test your slum cone in lower water cement ratio concrete, that slum cone as it is you will observe after the removing. Okay, so that is not what we want, because for high rise building pumpable concrete is required with high strength. So in such cases the workability is very important. Okay, the need of compaction become apparent for the study of the relation between the degree of compaction and resulting strength. Why compaction is needed? Because once means compacted concrete is you will get the higher strength. If there is a porous or voids created between the particles, then you will not get that much strength. So that's why the compaction is very important. And if it is workable concrete, it will be easily compacted. That's why that self-compacting concrete is special concreting used for the high performance base elements. So what are the factors affecting workability? Water cement ratio, mix proportions, size of aggregate, shape of aggregate. Okay, water cement ratio, as we have discussed in first unit also. If we are increasing more water, your concrete will be more flowable. But its second part is what is that your strength will be reduced. So maintaining water cement ratio and increasing the workability, we can add super plasticizer into the concrete. So that's why the water cement ratio is affected to your workability. Then mix proportion. If your mix proportion is not proper, your workability you will not get. For example, if you are using finer particle more into your mix design, finer particle in the sense sand content, if you are using more into your mix design, then its effect will be on the workability. How? That finer particle having a more surface area which require more water demand. So that's why the ultimately effect on your workability, because it absorbs that all water onto their surface area due to its finer particle, and your water will be desired workability water content will be less. So that's why the mix proportion is also very important. The proper mix design through we can calculate the our mix proportions. Then size of aggregate also affected. In first unit also we have studied the various sizes and textures of the aggregates, flaky, rounded, on all these things. So that is also in that unit also we have discussed, if rounded aggregate we will use into the concrete, you will get workability, but you can reduce the bonding capacity between the each particle due to its smooth surface. So this is the effect of size and shape of the aggregate. Then again surface texture also affecting to the workability. If so smooth surface texture is there, you will get workability. Okay, but you will lose the bonding capacity. Whereas in rough structure of the aggregate, you will get um, more means binding capacity, but the less workability. So likewise, the surface structure is also important. Then grading of aggregate and use of admixtures. As we have already discussed, without changing our water cement ratio, we can increase the uh, means our workability. But it is very important that when we are using the admixtures into the concrete, their mix dose has been very carefully selected, because if we are using a more higher or higher water reducing admixture, then it can be affected to the strength. So the finalizing the use of admixture or dose of admixture, it is very important. Then there are some laboratories testing methodologies for calculating the fresh concrete. These are some common tests which are available in every laboratory to measure the workability of concrete, like slump cone test. IS 1199 is giving the guideline regarding this test, slump cone test. So what is the procedure there? You can observe in this figure. This is the slump cone. This is the tamping rod, and with this tamping rod, we have to fill the concrete into that cone, and layer by layer. And after filling the level of top surface, that mold, slightly we have to remove. And after removing that cone, we have to observe how that concrete will be collapsed. Like in first case, you can observe here the completely collapse is there. Second one is shear type collapse, means partially that slump concrete slump was collapse. And third one, true slump, that is the bulging from side, and it slowly goes down, means like compressed figure we can observe here. So this is nothing but the true slump without shear or without complete collapse. Such figure or slump we can consider for our good concrete quality. Okay, so this meaning is nothing but that the our completely homogeneously concrete mix is well prepared. So that is the reason behind this. We require the true slump. Okay, so the procedure is simply whatever our fresh concrete we are prepared, that we have to fill into that slump cone in the layer by layer. In three, we generally we are using fill it by the tamping rod. First layer we are filling that concrete, then again tamping 25 times of tamping is required for each layer. And after the fully compacted that slump cone, slightly we have to remove on upper side the slump cone. So this is the slump cone, and after that this stamping rod sometimes have given a scale onto that. So with that scale we can measure this slump height. Okay, so this is the slump cone. Then the second method is given into laboratory, that is compaction factor. You can observe in this picture that slump cone apparatus. This is nothing but the slump cone apparatus. It having a two hoopers attached uh, on over each other, and at bottom one cylinder is there. So procedure is that once we have prepared our concrete mix, fresh concrete, we will place into first hooper, that is top one, and below that hooper, its opening has been closed. Okay, there is one small door that we have to close at the time of filling that upper hooper. Okay, then after filling that complete hooper, then slide that bottom gate, we can say gate it is, of that hooper, where to remove. What will happen? The completely filled with the concrete, that top hooper, the complete concrete will be collapse into the second one hooper, means bottom one hooper. Again same thing we have to carried out in this hooper also. After the filling, this second hooper, we have to remove this bottom one, its gate. Again, that second hooper concrete completely fill into the bottom one cylinder. So in this between, we have already measured this empty weight of the cylinder, bottom one. Okay, have you seen this figure, students? It is visible to all?
Yes, sir.
Yes, sir.
Okay, okay, good. So after the taking empty weight of the cylinder, this say from second hooper, the concrete will be collapsed or fill into that this bottom one cylinder. Then without any without we have to any compaction, we have to take measure the cylinder with the filling of that concrete without any compaction. So that is your partially compacted concrete weight. Initially we have to take empty weight of that cylinder, second one partially fill concrete weight, and after second time means third weight we have to take that about the fully compacted concrete. Means you have to take this cylinder on the vibrating table and fill it again by remaining concrete completely up to the top surface, level that surface, and again you have to take that weight of that cylinder. So that will be your fully compacted weight we can consider. Okay, so that is nothing but the your compaction factor. So how can you calculate the weight of partially compacted concrete? As I told you, in the second, when it will be filled by the gravity of from the second hooper concrete into your cylinder, that is your partially compacted concrete. And after vibrating your that cylinder and filling more concrete into that one, that is your fully compacted concrete. So their ratio is nothing but the compaction factor. So here recommendation is that the slump cone is generally used for the normal concrete, whereas the compaction factor test is generally used for the stuff concrete, means quite uh, harshly concrete. Okay, so this is uh, about the compaction factor. The some of the means of value is suggested by the IS 456 that compaction factor should be between 0.75 to zero point 0.8. But in practice, it is observed that if the compaction factor is more than zero point 0.8, it will be very good concrete. Then third test in laboratory which measure the workability, that is VB consistometer test. VB consistometer test. This is the picture of that test or apparatus. Here is the bottom one. There is a vibrating table. We can say small. On that vibrating table, there is one platform. One cylinder is there, and in that cylinder, with the help of that stand, there is a like same similar to like that slump cone, but it is in small size. So that slump cone is put into that cylinder. It is a sealed cylinder from the bottom, and the method is that our whatever our fresh concrete mix is there, we have to fill with this top we can say funnel concrete into that our slump cone into that cylinder. Okay, after filling that slump, same method is there. We have to tamp at the time of filling that cone. It is very small size. I don't know you are visible or not. The left side figure has given dimensions of that instrument. Okay. So the after the filling of that cone with the help of glass plate is also is attached to there. We have to level that surface of the cone. Okay. And after that we have to remove that slump cone and starting the vibration. So at that time we have to measure the time also. So with that way there is also a scale. We have to measure that time and scale. Okay, how much it will be slump goes down. So it is a similar way of that slump cone test. Just only this slump cone we can use on the vibrating machine. Initially that slump cone there is no any vibration required, but in this machine a vibration table is already attached to that one. With the help of vibration, how much this slump will get, that we have to check. And similar to that compaction factor, this matter is very suitable for the dry concrete in the sense where lower water cement ratio concrete. As I told you that the very harsh concrete will be made when we are going for the lower water cement ratio. So for such concrete we can measure the slump through the VB consistometer test. Yeah. So this is the general values given in a book with reference to the how can we check the whether our concrete will be very good or not in terms of rheology or workability. For slump value is their compaction factor and VB consistometer test. So these are the not standard values, but just for a guideline whether our concrete is achieve that desired workability or not, that we can finalize. Then last one, uh, this is the flow table test for the measuring the workability of concrete. The flow test is used to measure the workability of high or very high workable concrete. Means like self-compacting concrete is a very flowable concrete, or pumpable concrete that is very flowable concrete. So all these flowable concrete can be used this flow table test to measure their workability. Okay, it gives an idea about the quality of concrete with respect to the consistency and cohesiveness of the concrete. Nowadays, this instrument attached with the help of motor also. Instead of this handle, nowadays means electric motor are available to attach with this instrument so that it will be automatically vibrated. Vibration in the sense this you can see the top surface of the there is a one steel plate, and on that steel plate there is a small like a cone. Okay, so in that cone we have to fill the concrete, and with the help of this handle we will just uh, give the one type of vibration to that surface. Okay, it will goes up and down like that. It will get vibrated so that the vibration jerk will be given to that concrete whatever we will fill into that cone, and slightly it will be uh, that collapse of the concrete we can observe. So what will be the test procedure? As I told you that clean that mold and that steel plate, place the cone onto that, then now fill your fresh mixed concrete into that cone with the help of tamping. Then remove, then lift the mold or remove that mold vertically upward without any supporting, so that that concrete will not be collapsible. After that, table rise and drop as I told you with the help of that handle, or nowadays there is a motor attached to that one to operating that machine. Then for 15 seconds. Next, they measure the diameter of the spread concrete in about 6 directions. Means after removing this, after vibrating this, whatever the concrete will be collapse. This is a circular plate. So how that concrete will be flow in 6 direction, we have to measure their dimension distance. So that will be your uh, flow table test to your measure the flowability of concrete. Along with the students, for measuring the flowability, uh, special concrete like self-compacting concrete, it is very high performance concrete, like in both way, whether it is high performance in the sense high strength or high workability. So in high workability concrete like pumpable concrete, they are having some standard test like L type box test, then V funnel test. These are the generally tests we use for the self-compacting concrete to measure their flowability into a, with respect to time. Okay. This is for just your general guidelines. Then second most part is when we are going for the uh, workability testing or fresh concrete properties. In mostly cases, we will observe the segregation and bleeding. What is segregation? It is defined as the separation of ingredients like sand particle or aggregate particle materials into the concrete. It's separation. That is nothing but the segregation. Separation in the sense after you are making fresh concrete, if you will place somewhere or in that your slum cone also you will observe this one. When you are remove that slum cone and your that concrete collapse like it just aggregate is suddenly separated from that complete homogeneous mix, then that is nothing but the segregation. Means it is a separation of aggregates to each other. That is your segregation. Means there is no any homogeneous mixture forming or bonding they are forming. Okay, so segregation and bleeding will not uh, acceptable in any case of the concrete. So what are the factors affecting to that segregation? Mainly your water cement ratio. If that water cement ratio will be vary, the binding capacity between the particles will not get if more water cement ratio is there. Coarse aggregate settle down in the concrete mix at the time of concrete mixing. If you are particular mixer are using for the concrete mixing, in that case you will observe that the separate means at the time of mixing a larger particle, that is your coarse aggregate having larger size, so it will be settled down due to less bonding, so that will be also affect the segregation. Then mix proportion not means as per mix design, if you are prepared, such thing will be happen. So we never accept the segregation and bleeding into our concrete. Then bleeding is the uh, uh, is nothing but the your cement paste comes onto the surface of the concrete. So that is bleeding. When you are placing your fresh concrete into particular formwork, and after vibration you will feel that the completely cement paste will be comes top surface of the that concrete, then that is nothing your bleeding. Or from this formwork, if there is some leakages is there, gap is there into your formwork, the completely cement paste is flowable through that cracks, so that is also bleeding. It is mainly affected due to the water cement ratio and higher water higher admixture dose. Okay, so this thing also will not required because cement paste is we can say heart in our concrete, because the complete hydration process, whatever the binding property are all into the our cement paste. So we have to very careful about the at the time of mix calculation of mix proportion and calculation of the finalizing the dose of admixtures. So shrinkage, separation of aggregate, that is your segregation and bleeding, we never accepted into our fresh concrete. That's why the supervision is needed at the time of the placing of concrete into our formwork on site. Then methods to avoid the segregation and bleeding. What we can do to avoid such thing happening? So maintaining your water cement ratio strictly. Okay, generally we are observed on the site, the contractor, because he is not literated that much. So what he do, if he feel that concrete making very harsh, so compaction will be more required, vibration will be more required on site, he will decide itself to increase more water into that concrete, so that it will make a very well compacted concrete. But we know that after, if we are adding more extra water into the concrete, there will be effect on the strength. So site supervision is very necessary at the time of concreting. So water, we have to strictly follow the water cement ratio what we have given in the mix design. Proportion also we have to strictly follow as per the mix design. Avoid over vibration. Okay, why we are giving to vibration to our concrete? To remove the just in the air voids, whatever the airs bubbles will be formed during the mixing of concrete ingredients, that air bubble we have to remove, so that there will be no forming of honeycombing. Okay, so that's why we require vibrations to that particular elemental concrete. So due to over vibration, what will happen, the heavy particles will be settled down, and that cement paste will be go up. So such thing concrete also not acceptable. We will not get a good result after the completion. So avoid over vibration. Proper equipment also necessary to mixing the concrete. Okay, and using admixtures, as I told you, to fixing the dose of admixture is also very important. Slightly you are increasing the dose of chemical admixture, concrete makes a very flowable, and it is also affected to your setting and hardening of concrete. Okay, so these are the some uh, methods to avoid desegregation and bleeding in concrete. Then the process of manufacturing of concrete. Okay, so this is your very important part. After you are mixing your concrete, the testing, after testing fresh property, your concrete will be now ready for the your placing into your formwork. Okay, so there are some standard procedure is there to manufacturing the concrete, like testing of raw material, as we have seen in, say, what are the test on cement, what are the test on aggregates. Then batching of ingredients. Batching in the sense, after the proper mix design, what are the proportion calculated, that how to we have to batch for the concrete mix. Then mixing of ingredients, how you can going for the mixing that complete ingredients through manually or through machinery, their methods. Then transportation of concrete. Transportation in the sense, If suppose there are ready mix concrete is available from one place to other place, your concrete will be transported. Okay, so that is nothing but the transportation of concrete. Then placing of concrete. Placing of concrete means underwater construction. If you are going on, how can you place there? High rise building is there. How can you place your concrete to that much level? So that is the placing of concrete, vertically or horizontally concrete placing. Then compaction of concrete. Compaction of concrete in the sense with the help of manually tamping to that concrete formwork or by vibrating. So these are all related to your compaction of concrete. And in the last, that curing of concrete. After the compaction or placing of concrete, the curing is very important. Without curing, means there will be a chances of cracks develops into your concrete, because curing is maintain the hydration process into your concrete. Okay, so this is the exactly methods we have to follow for the good concreting quality.